This podcast is supported by Siemens, your partner for industrial-grade AI.
Hi there. Welcome to a new episode of the Industrial AI Podcast. My name is Peter Seberg. I'm your host, and today I'm going to be talking to Richard Rovner. He is the Vice President of Marketing at MathWorks. And today our topic, how could it be different, is going to be AI in engineering. We're going to be looking at past, present, and future. Hello, Richard.
Hello, Peter, and thank you very much for the opportunity to appear on this podcast.
You're very welcome. Let's start with you, please, introducing yourself to our listener.
Absolutely. So, as you said, Richard Rovner, I have been the Vice President of Marketing at MathWorks for very, very close to 25 years now. I've been there almost 25 years. Prior to that, I worked at a software company called SAS, which is a statistical software company. But prior to that, I was a computational statistician and dabbled in AI back in the late 80s and early 90s. So I've had some exposure to AI for decades now, and it's been exciting to see it evolve over that time to where it is today, and excited to see where we go from here.
Amazing. 25 years with your company, MathWorks. Is the one that you were, the other one before SAS, is that the one that you were, or was it only even another one? Because as I had the opportunity to listen to your keynote presentation, you were referring to, was it a short period only at FAW in Ulm?
That is correct. So as I was finishing up a graduate degree in computer science, I had the opportunity to go over to Ulm back in mid-1989, and I spent a full year there at the FAW doing image processing research using artificial intelligence. It was a form of neural networks, and what we were trying to do was detect anomalies in otherwise normal images. So I spent about a year there, and then I went back one more summer. So I spent about 2 years off and on in Ulm and away from Ulm working on that project.
You were always going to go for this famous quote. I'm sure that you've heard it before in German, but Ulm, for those people from around the world who are not aware where Ulm is, it's a city, I would assume, is it roughly 100 kilometers maybe west of Munich, roughly?
Yeah, I think so. The birthplace of Albert Einstein, and I believe home to the tallest church steeple in Europe, the Ulmer Münster.
Oh, wow. Yeah. The second one, I saw something. Maybe there has become a bigger one in the meantime, but I'm not going to be certain about that one.
Oh, okay.
And the first one, I wasn't even aware. There you go. Learned something from you already. Thank you very much. Yes, as I suggested, I had the opportunity. Thank you to your colleagues to having been invited to the MathWorks Expo. That's only a couple of weeks back. And that was quite a conference, I must say. It was held in what I believe is an American hotel chain in the ballroom, which for me as a European was impressive. And it felt like you had a completely filled out conference. It was an amazing thing.
We did. We were very excited. We have not had the expo in Germany since prior to COVID. So this was our first return of MATLAB Expo in Germany since COVID. And we were thrilled to get close to 700 customers attending. We had a full ballroom. We had parallel sessions in the afternoon, generally very technical sessions, hands-on workshops. So it was a great opportunity for our customers to get exposure to what's new in MATLAB and Simulink, and also hear from their colleagues about some of the nice novel applications of our tools to engineered systems and engineering design applications.
Yes, I could experience, including what I was there for the afternoon discussion round. You and I didn't specifically meet, but I guess we saw each other. You could experience the very high interest of the people who stay there until the very end to be networking together. Now, the first one of the major takeaways from your presentation for me was the fact, and you already mentioned it almost just now, that you were doing AI as you were even before MathWorks, but it was the fact that AI has been part of the MathWorks journey for such a long time. And for that reason, on purpose, I used this subtitle as past, present, and future of AI in engineering. So let's start with the past. When and how became AI part of engineering at MathWorks?
Well, yes, we have been involved for since the early 90s. As I said in the talk, listeners will forgive a bit of simplicity. A pretty fundamental mathematical construct underlying AI, certainly neural networks, is linear algebra. And everybody who knows MATLAB knows it's a matrix at its core, a matrix calculator that just loves linear algebra. So, in fact, MathWorks released Neural Network Toolbox back in 1992. And 32 years ago. And since then, we've been adding capabilities and features in that product as well as other products, sort of incrementally as the technology advances and the applications become more visible. So that's when we first made AI formally available through our product back in 1992.
Right. And yeah, there's always going to be disagreement on what exactly we mean regarding the definition of AI. But I think you're perfectly fine with saying, with the linear algebra, that's where, from your perspective, you started. Now, I do recall that you were showing some kind of timeline, and I'm not expecting you to have exactly specifically in your brain each of them, but there are so many different words very specific to this journey of AI that I myself have been in for the last, let's say, 10 years more specifically and more general before then. So are there maybe a couple of features, a couple of introductions relative to AI that you can share with us from those last 25 years?
Yeah, I would say, as I said, it started in 92. And then I would say for probably 2 decades, we kept adding features to the product and evolved as the market evolved. And then, as probably many, if not most of your listeners know, in 2016, we had, let's call it the GPU moment or the deep learning moment. And that's kind of when the world pivoted a bit and realized we could train deep neural networks very efficiently using GPUs. And we at MathWorks certainly kept current with that technological shift. So after 2016, we started to release products like Deep Learning Toolbox. We formalized more machine learning methods in the Statistics and Machine Learning Toolbox, Text Analytics Toolbox. And we built apps into our tools. I think one of the reasons that MATLAB and Simulink have been loved and used for decades is one of the primary things we focus on is ease of use. We want to make algorithmic development accessible to all engineers and scientists. And so I do want to point out, we built apps, point and click graphical user interfaces into our products to enable things like working with classification and regression trees, designing deep neural networks, doing labeling for signals and video. We've really tried to make those capabilities very accessible to our users. And then as we moved into the 2020 timeframe, we started to work with our customers as they developed embedded systems leveraging AI. And so our whole tool chain flows all the way from algorithm development through to deployment through code generation. And we built tools to enable our customers to deploy AI on the edge with code generation and target-specific library support and things like that. So we've been continuing to add capabilities through the entire workflow from concept creation and algorithm development all the way through to deployment and operation in the real world, through digital twin technology.
Oh yeah, right. That's really amazing. As I said, I was really impressed by the fact, as you were saying, that AI has been kind of embedded in your products for a very long time. But let's move then to what it is specifically. And we talked a little bit about before what people would consider to be AI. What is it that today you are offering that you would call specifically, AI embedded solutions? Maybe you have a use case example or two for us.
Sure. I think what we are seeing is more and more of our users incorporate AI into model-based design, which is the framework we've talked about also for decades, about how you use models and modeling and simulation to design, develop, deploy, and operate engineered systems. So today, we are enabling AI capabilities throughout the entire workflow of model-based design. So an example, well, we talked about this at the conference, so I'll use this example. Coca-Cola is a company that has, I think they're called freestyle machines. And what they are, I don't know if anybody's seen these, but you go up to the machine and you can customize the beverage mix for your drink of choice by pressing a few buttons on the front of the machine, and then you get your individually customized beverage from the device. And part of the control system for these machines involves water pressure. And what they wanted to do was be able to control the machine through understanding what the water pressure was. But rather than adding a sensor for water pressure, a new physical sensor, which of course would have added cost, maybe some complexity, potential hardware support, etc., they used machine learning to be able to predict the water pressure from a separate, already existing signal that was measuring current. And they used data to build a machine learning model that came within plus or minus 10 psi of the actual pressure, which was sufficient for their application. But so they were able to enhance this machine through software, in fact, through machine learning, AI, rather than through adding hardware and the complexities that come with the costs and complexities that come with hardware. So that's and then they were able to generate code. I mentioned code generation. Once they had that machine learning model the way they wanted it, they used code generation within model-based design to target their particular processor. I think it was an ARM Cortex-M processor in the control module. So that's an example of a workflow from concept all the way through to embedded AI.
Great example. I haven't seen the machine yet, but maybe I'll run into it. I'm looking forward to. As you talk about code generation, I happen to have seen your webinar introducing the MATLAB copilot. That is something of today as well. Can you share with us what the engineer can do today within your MATLAB environment?
Yes. So as you correctly pointed out, MATLAB Copilot came out back with the 25A release. So it's available now for all users using 25A and, of course, 25B. It's essentially a customized AI assistant for MATLAB. You can use it to help you generate code. You can use it to explain code. You can use it to automatically comment code. You can run it with other products like our MATLAB test product to automatically design tests for your MATLAB code. So it's just scratching the surface. This has been out for 2 releases now. We will continue to add to it every additional release with more features and capabilities. But people should think of it again as their customized AI assistant for MATLAB.
Okay, very good. I'm going to be asking you later on, kind of as a more towards the close of the end, what your first experience has been, or more specifically, what the experience of the first users, of the first customers has been. That's a topic which is very close to my heart, so to say, how the engineers, in general, how consumers are taking up AI use cases, solutions, but in this case specifically how the engineer is relating. But we'll do that more towards the end. Let's move into, and thank you for those examples of what specifically today you're offering to the engineering world. Let's move towards where you see, and I guess, with the copilot, maybe as one example, already in today's world, moving into the future. What is the future of AI in engineering going to bring us? Do you see any structural changes with regards to AI in engineering?
I don't know that we would say there will be structural changes. I think our view is that the way engineering has been done and will be done will essentially remain the same from a process perspective, but that AI will become more and more ingrained in that process. And what we've talked about is sort of think about the design loop, going from sort of concept all the way through to deployment, and then continuously improving the engineered system through a loop. So we're seeing essentially two fundamental ways that AI is enhancing that design loop. One is, and this was the example from the Coca-Cola machine, injecting AI algorithms within the loop, within the design itself, as a component of the design. So the case I talked about was the AI component was that machine learning model. So we're seeing that happening more and more AI models being incorporated into the design as part of the design loop. But the engineer is still, in this case, really driving the design loop and setting the constraints, setting the parameters, exploring the design space, but utilizing AI algorithms more and more. The alternative is where the AI is partnered with the human outside the design loop and is in fact influencing the overall design loop itself. Let me give you an example of what I mean by that. And this was a pretty interesting example. This is Max Planck, and they are measuring gravitational waves, as I think most people know. And one of the systems to do that is a set of very, very complicated and precise mirrors and lasers. And up to this point, those controls were all done through the human in sort of classic control engineering. But what they did was they figured out that they could train, and I'll call it an AI agent. So here we're introducing the concept of agentic AI. They could train an agent to learn how to control those mirrors and those lasers. So there were two AI aspects of this. One was a model of the system, a machine learning model of the system. Actually, it was a deep neural network based on the data from the system. So let's call that the AI component. But the agent was a reinforcement learning algorithm. And they set up different reward functions and different constraints and constraint requirements and allowed the agent to explore the design space. So here you have an agentic AI operating sort of in partnership with the human, but allowing the agentic AI to explore the design space. And so those are two kind of fundamental ways to think about the design loop and how AI is being incorporated as components within the loop itself, and then through agentic methods, managing the design loop from the outside in.
Right. Interesting that you combine the terminology of agents with reinforcement learning. And when I saw that, whenever I see reinforcement learning, it brings me back, I guess it's about 5 years ago. It was Hannover Messe, Festo, Jan Kutnik working with Jürgen Schmidhuber. And he was saying they had like this production line, in the future, we're going to just have a reward function, as you were referring to, telling the algorithm what it is it should design for us. And that's, I guess that's very closely related to the agent perspective, loads of discussion around agents, but it's wonderful that you give an example here with people saying, oh yeah, we've had that for a long time. These days, though, we're talking about, I guess, AI agents, and maybe that's bringing me towards the next question. I'm not sure you already implicitly were referring to the inside outside. So if I ask you what generative AI can be doing for engineers?
Well, I mean, we talked a little bit about the copilots, and that's a classic example. That's the most visible example of generative AI, is being able to have these models generate code, test code, interpret code, explain code, and you can see where this is going eventually on the Simulink side, being able to generate models, explain models, interpret models, test models, verify models. I mean, this is just the beginning of where we see generative technologies. Companies building their own large language models based on their own proprietary IP, and then deploying these types of technologies for a competitive advantage. So it's just getting started, and it's a pretty exciting time to see where this is going to go.
Right. Now, the Copilot for MATLAB is available for, I understand, for your customers to use, right? Can you share with us how, if I believe you are going to be bringing GenAI to Simulink as well, and can you give us an example of how that would look, what that could be doing, and can you tell us when your customers can expect it?
Yeah, the plan is for Copilot capabilities for Simulink in 2026. And what that will do is that will be, I mean, think about that as a customized AI assistant for Simulink, analogous to MATLAB Copilot is customized for MATLAB, but it'll speak the language of Simulink. And so it will help over time. The vision is, of course, as I mentioned, to create models from natural language, to explain existing models, to test models, to verify, to help incorporate requirements. So use natural language to map requirements to models or create models from requirements. The vision is the whole model-based design flow that's enabled through Simulink will be augmented with AI. Now, the thing I want to talk about, I mean, AI also, as we've talked about, it generates code. One of the things that I think everybody knows, but it's important to reinforce that these AI systems can make mistakes and code can be imperfect. And so engineers in particular, especially working on safety critical systems, really need to understand that. And they really need to design their approaches, their workflows with that, I'll say, expectation, let alone understanding. And our view is that a model-based design approach allows you to ensure you're developing a system that is functionally safe and meets all of the requirements. It allows you to design the verification and validation of the system in a repeatable workflow. That's the other thing about these AI systems are not deterministic, and that's not what you want in a safety critical system. And so we really see the importance and the benefit of what we're calling sort of AI-enabled model-based design. I mean, the line that I like is AI can generate code and automate workflows. Model-based design proves it works.
Okay. Yeah. I've been spending a lot of time and continuously do. And the first example, hearing you talk about exactly the requirement is that I think, the good example is always an airplane, right? And sure, we would like, I guess, and you talk about inside, outside in the combination to come up with, let's say new designs. And I would like to be able to choose one and do the work for me, engineer, as much as I can be helped. The question then specifically would be almost like, because it's exactly these guardrails, because the final system where the rubber hits the road or the plane in the air needs to be deterministic. Can I expect kind of the software to your solutions to be helping the engineers, kind of suggesting those guardrails, or maybe they come to me implicitly?
Well, yeah, you can design your workflow to ensure that you are staying within whatever guardrails are appropriate for the engineered system that you're building. And the other point I wanted to make, you talked about exploring different designs. One of the nice things about modeling and simulation, and now sort of AI-enabled simulation, is the ability to explore a wider aspect of the design space much more quickly. You can synthesize data, you can synthesize scenarios. So that will be pretty exciting because it will allow engineers to explore the space more quickly than they could before. But at the end of the day, when you move to implementation, you want to follow a well-designed workflow where everything is tested, everything is validated at the component level, at the system level, at the system of system level. And yes, to answer your question, our tools and the model-based design approach enables you to develop a proven, workable system, even while you're incorporating these new advanced AI and other technologies.
Very good. Yeah, so you don't see any structural changes as we did start talking about using AI, to help us, the engineers, come up with, maybe completely new ideas that we haven't thought of before. I believe I'm going to now make a huge jump by asking you a question I did in the afternoon as well. I think I asked it from Professor Stark from Berlin. It's about democratization, let's say, of AI in general. As far as I recall, AI, and we talked about the definition for the consumers, started roughly 10 years ago. It was about translation. These days, the consumer can make translations at whatever, 99% or close to 100% quality, which was not possible 10 years ago. Since a couple of months, the consumer can produce pictures, in the meantime, video. So you feel where the question is going to be heading. Maybe you do recall the question as I asked it, which is when, if at all, will the consumer be able to ask an LLM, a piece of AI, for a product that came to their mind? And the LLM, the agent, maybe, somewhere finding your solution or another solution, engineering solution, will come back with a proposal and will have it produced and a mock-up sent to the consumer.
Ha! Well, you're asking me to predict the future, which is always difficult. What's the expression? The best way to predict the future is to invent it. So
to do it, yeah, right.
And so I certainly don't know when that capability will be available. I mean, having been at MathWorks for 2.5 decades, I get ingrained in my brain probably almost every day, certainly every week, the importance of correctness, quality, safety, repeatability. And so that would be the one thing as a personal opinion, I would worry about is when we get to a world, well, yes, it can conjure up something, but is it going to be fit for purpose? Is it going to be of sufficient quality and safe if it's a safety critical system? I think, our customers will be building libraries and they will be developing components that are repeatable and systems that are repeatable and can be applied. We have customers doing this today where they can use models and store a library of models, and then they can fit different models and different components for different applications without having to reinvent the wheel every time. So our customers are doing this today, and the ability to incorporate AI into those models will only make that more impressive. But when the actual individual consumer can do that, boy, that's it's hard to know exactly.
Yeah, it's obvious that it was supposed to be a question along the lines of Asimov. Maybe that's actually Asimov, the name of my company, looking into the future. But to stay a little bit with it, would it be realistic to say that the share of the generative the creative, generative, but not only. Let's just stay at the share of work, looking then maybe the 25 years back when you started, then today, and then looking whatever, 25 years or just a couple of years into the future. Would you say that maybe possibly the tools that you have been providing to the engineer and that you will continue to provide to the engineer, could it be that they will take up a higher share of the total sum of what comes out at the end relative to the engineer?
Well, okay, yeah, I see where you're going. I would say it, yes. I think the role of the engineer and the way the engineer works will evolve, and they will work at a higher and higher level of abstraction. So more and more of the low level, I don't like that expression, but let's say the more repeatable work will be automated through AI and agentic AI. And engineers, again, will be working at a higher level. So I think some skills that engineers are going to have to develop to work at this high level. First of all, AI literacy. They're going to have to keep current with how these AI tools are evolving and what they are capable of, as well as what their limitations are. They're going to have to think more and more at a systems level because, again, some of the lower level components will be more automatable. So the individual engineer or teams of engineers will be working more at the system level. I think they'll need to be agile. The technology is changing so rapidly that we have no choice but to be agile and be able to understand when we can adopt and incorporate new technologies. Collaboration is going to continue to be important. No single discipline will be able to innovate alone. These are still multi-domain and multi-discipline systems. And so engineers working at a higher level are going to have to collaborate across the different disciplines and domains. So, and organizations, if we talk about large organizations, they're becoming increasingly global. So communication across boundaries, cultures, languages will continue to be important. So I think those are 4 or 5 ways of working that I think will become more and more part of how engineers get their job done in the future.
Right. Before we come to a close, Richard, you almost in a natural way moved towards 2 topics that I quickly want to touch on, which is talent and transformation. I suggested it kind of at the beginning. Do you have first experience, more so from your customers, I assume, maybe from internal, but your colleagues are building the product. So more so from your customers, from the engineers, for them to train, to find, to empower them. How open are the engineers to using the type of products that you add to what it is that you have been providing them with for a long time?
I think individual engineers are generally pretty excited about all of this new technology. And so my sense, and I can speak personally to my own organization, individually, there are many people who embrace these new technologies and use them literally every day. I think where we're seeing a little more caution is at the sort of the organizational level. There are a lot of questions around protection of IP, protection of data, again, safety and quality. So I think we talked about this a little bit during the conference. Organizational cultures are maybe a little bit slower to adopt these new technologies. They're much more careful, much more methodical, much more thoughtful about how we're going to apply these in their organizations. So it's sort of this yin and yang of the individual. There are individual engineers who are embracing it, but many organizations are embracing it as well. But generally, a more methodical approach, and that's how we've generally approached it in our development, is very, very thoughtfully and very, very methodically. I think that's sort of the nature of the world we come from in engineering. Is we want to make sure that things are right. So in academia, it's interesting. I would say what I was hearing from the team that works every day with professors and students was maybe a year or 2 ago, there was a fair amount of trepidation and caution about how this technology was going to be used in academia. What I've heard in the last year is that's kind of flipped a little bit, and there's much more enthusiasm and much more excitement in the last year. I think people are figuring it out. Students are figuring it out. Professors are figuring it out. And it seems like we've kind of turned the corner a little bit in academia. And I'm pretty excited to see where that goes from this point forward.
Okay, yeah, you suggest the engineer is in general a very open type of person. Not sure you have heard maybe, or you recall from your time in Germany, there's the saying for I try to do it roughly in German, for the Ingenieur, nothing is too schwer, which means for the engineer, nothing is too difficult. It's kind of a proud remark of the engineer, the engineer that is capable of doing things. Now, the final one then on the transformation, interesting you refer to the academia, and I did join your second smaller session as well. And that moves towards culture when you say academia, and I'm going to combine it with the question if technology these days is moving maybe not too quickly, and maybe that's related to the academia where students start and then before they have finished their course, they see around them, they see everything changing. Now the question is like, can culture, and then that was part of the discussion we had, can culture be changed? Because that was a central, we need to change our culture. And I was saying, can we change culture to bring it all together? How do you see the role of MathWorks in this ever more quickly changing environment that you will be playing the next couple of years?
Yeah, you're right. We did talk a lot about culture and whether and how cultures can change. With respect to our role, we at our core are a tools provider, and we view our role as continuing to deliver the software and the services that support that software to give our customers, our clients, and our users confidence in our tools. We focus very, very diligently on very, very thoughtful and methodical applications of new technologies. We test and test and test. We work with our customers and get their feedback all the time to make sure that we're meeting their needs. So we view our role is, at least from a technology selection perspective, they can have confidence. The culture and the way they adopt technologies, that's going to be unique to every organization. We can certainly help our customers and do help our customers adopt our technology through pilot projects, proofs of concept. That's one of the nice things about our software is you can quickly and easily prototype and work on proof of concept projects to give teams and organizations confidence in model-based design and AI-enabled model-based design. But again, our mission is to deliver the software and services in a high-quality software and services that take the worry out of the technology and let our customers innovate and build the engineered systems of the future.
Thank you. Final question, Richard. Tell us a little bit about your team, maybe. Where are you based? Knowing that you have a global organization, maybe you are looking for talent within your direct or people around you in the organization. And if so, what should interested parties bring?
Yes, MathWorks is a global company. We have about 6,700 staff all over the world. The marketing organization is about 430 staff all over the world. We have technical people. We have product, industry, and education marketing teams that are highly technical, many with PhDs. And of course, we have technical in a different way. We have systems people, data analytics people. We have communications professionals, planning professionals. So it's a pretty varied organization. It's one of the reasons I love what I do what MathWorks does is motivating to me personally. And our team is just wonderful. And I learn something new every day and I laugh every day. I don't think you can ask for much more than that. So yeah, we are always looking for people across all roles in marketing all over the world. And if anybody's interested, they can go to our website or reach out to me and we'll see if there's opportunities. It's an exciting time at MathWorks, and it's an exciting time for engineering in general.
I would agree with that. Great close. If you are interested, dear listener, want to learn something every day, want to laugh once every day with or further away from Richard, feel free to. Richard, thank you very, very much for this interview. It was a lot of great thinking, great sharing, where your company, where the technology, where AI and engineering is moving. Thank you very much.
Thank you so much for the opportunity. I really appreciate it. Take care.
You're welcome. Bye-bye.
Bye.